figure skater is spinning with an angular velocity of 15 radians per second. She comes to a stop for a brief period of time, and during this time, her angular displacement is 5.1 radians. I'm trying to determine her average angular acceleration in the time during which she comes to rest. So I know that we are given her final displacement, which in this case is called her theta final. And that's 5.1 radians, and that her initial velocity is 15 radians per second. I am also going to infer that the initial time is 0 seconds because I'm trying to find the change in time. So it's going to start from 0, and I'm trying to find the final time, how long it took her to get to rest. And the initial displacement is also 0 because her final displacement is 5.1. So she traveled 5.1 radians, and that's from 0. So the first thing I want to do is find her acceleration during this period. So since I don't have time, my kinematic equation that I am going to use is v final squared equals v initial squared plus 2 times acceleration times the displacement. So changed into the angular form would be the angular velocity squared equals the initial velocity squared, angular, plus 2 times acceleration, the angular acceleration, times the angular displacement. So I know that her final velocity is 0 because she's coming to rest, and I do know her initial velocity, and I'm adding 2 times acceleration, and her initial displacement is 0, like I said above, so I can take that away. Now I'm trying to get the angular acceleration by itself. So that means that I need to put the initial velocity, angular velocity, on the left, so that turns negative, and then I can divide by 2 final displacement. So now acceleration is by itself, and I can plug in. So I can plug in that the initial angular velocity is 15 radians per second, and it's squared, and it's negative because I have the negative sign before. And I'm going to divide by 2 times theta final, which is the displacement, which is 5.1 radians, and that comes out to negative 22 radians per second squared. So now that I have the acceleration, I need to find the time that she is stopped. So now that I have the time, now that I'm looking for the time, I can use the kinematic equation with time and acceleration in it. So I'm doing final velocity equals the initial velocity plus acceleration times the change in time. So I want t final, and I know t initial is 0, so I can take away that t initial, and I also know that the final velocity is 0 because she's stopping. So now I have 0 on the left side, and velocity initial velocity plus acceleration times t final. And I want t final by itself, so I can put it, I could subtract by the initial velocity plus acceleration. Well, I can subtract initial velocity and then divide by acceleration. So I have t final equals the initial angular velocity divided by the angular acceleration. And now I can plug in. So my initial velocity is in the negative direction because of this negative sign right here. So negative 15 radians per second divided by the acceleration that I just got up here. And all of that comes out to 0.68 seconds. So my final answer is that the figure skater is accelerating in the negative direction, which means she's stopping, and that's in 22 radians per second squared in the negative direction. And it takes her 0.68 seconds to do this.